Today we're going to learn on how to find the cumulative distribution function of a continuous random variable. Firstly, we need to understand the definition of a cumulative distribution function. Generally, we denote capital Fx as a cumulative distribution function. The cumulative distribution function is a function whose output is the probability that x is less than or equal to the input. For example, capital F of 7 is the probability that x is less than or equal to 7, capital F of 9 is the probability that x is less than or equal to 9. Now, you know that if we look at the graph of the probability density function, then the probability that x is less than or equal to 7 is this area. So capital F of 7 is the area underneath the graph probability density function up to x equals 7. So, capital F of 7 being the probability that x is less than or equal to 7 is the integral of the probability density function up to the limit x equals 7. So, in general, cumulative distribution function for a continuous random variable x with a density function small f of x is a function capital F of t where capital F of t is equal to probability of x less than or equal t. It is also equal to the integral of small f of x up to the limit x equals t. We often use t as the input to a cumulative distribution function. The reason is that when we have integrals like this we want to avoid confusion between the limit t and the variable x in the probability density function. Capital F of t is in fact given by the area under the curve probability density function small f of x from -infinity up to t as indicated by the shaded region. Okay, here are the most important things that you need to remember about cumulative distribution functions. The first one is capital F of -infinity is equal 0 and capital F of infinity is equal 1. Secondly, the probability of x less than a is equal probability of x less than or equal to a and this is equal to capital F of a. Whenever we have probability of x between a and b, ignore the equal sign. So, the probability of x between a and b is capital F of b minus capital F of a. Lastly, to find median we actually divides the area under the curve into two halves. So, if the median is m, then the integral of probability density function with limit -infinity to m is equal 0.5, which means capital F of m is equals 0.5.